Okay. Right. Okay. Hi, Ron Slusher Sr. here at the Arizona Science Center for unraveling the secrets on both People's TV and Blog Talk Radio to hear a talk called The End of the Earth, If Not 2012, Then When, by Dr. Ariel Anbar of ASU, a professor of director of Anthrobiology, and Dr. Micheal E. Smith, ASU, a professor of anthropology at ASU also. And I'll just pan around right here. And was that all the cards here? We'll let everybody see what's here at the Arizona Center. We'll come back around and show this beautiful little site. And I had a couple here help me out. And folks, you want to smile for the camera. And these good folks here help me out. And we'll go see what... And here we are inside where the presentation's going to be, and we'll just pan around this little room. Small little intimate crowd in here today, and you can see a general idea where we're at inside here, and we'll pan around, and hopefully we can hear everything and see all these few people on hand to watch this. By the way, this group is from Arizona State University. It puts on these talks, and this is the first time I've been invited, so this must be an ongoing thing. And we'll try to come as often as possible and just see what folks have to see in this neat little room as we pan around. So we'll sit down.
By the Center for Nanotechnology and Society at Arizona State University. My name is Jennifer Watkins, and I'm tonight's cafe coordinator. CNS-ASU is a research center funded by the National Science Foundation to study the societal, ethical, and environmental implications of nanotechnology research and development. As part of our mission, CNS-ASU sponsors monthly science cafes together in partnership with the Arizona Science Center. The cafes bring you, the public, together with university scientists to discuss how science and technology affect our lives. They are opportunities for you to not only learn from the people who produce and study science, but also for you to educate them by sharing your opinions, making comments, and voicing your concerns. Tonight's cafe is entitled The End of Earth, If Not 2012, Then When? And our presenters are Dr. Ariel Anbar and Dr. Micheal Smith. Dr. Anbar is the director of the Astrobiology program at ASU's School of Earth and Space Exploration and holds a professorial appointment not only in the School of Earth and Space Exploration, but also in ASU's Department of Chemistry and Biochemistry. His research interests include the study of geological, chemical, and biological processes that shape the Earth's surface environment and how they have changed through time. Dr. Smith is a Mesoamerican archaeologist professor of anthropology in ASU's School of Evolution and Social Change. His academic interests include ancient urbanism, comparative urbanism, and the economic and political organization of agrarian state societies. We will begin by hearing from Dr. Anbar.
Thank you. I'm going to stand up here. Can you already hear me? So I'm going to give you a bit of a scientific perspective on the topic, which is the end of the Earth. And I'm going to open by asking, I'm going to open by trying to change slides. There we go. By just asking how many of you have actually seen 2012? Maybe this so a minority of you. So I actually hadn't seen it myself until this past Sunday, because I figured if I'm doing this, I should probably see the movie. So how many of you thought and enjoyed it? Yeah, I thought it was pretty fun, actually, in spite of the science. For those who didn't see it, though, let me tell you just a snapshot of the science. It's pretty brief, because there's really not much of it. So in 2012, the premise is that, for some mysterious reason, the sun, the neutrinos being emitted from the sun, neutrinos, this is already getting to physics that's beyond what most people ever learned, but neutrinos are real, that really exists. Neutrinos being emitted from the sun change their properties somehow magically, so they start interacting with the Earth's core, heating up the Earth's interior and causing massive geological disruptions and flooding and sort of biblical scale kind of death and destruction, all in not glorious 3D, it's not Avatar, but other than that, glorious special effects. So in terms of the science of this, right, there's really not much to talk about. I mean, neutrinos aren't going to magically change themselves to suddenly interact with the Earth's core, as far as we understand physics, and there's no reason that should happen in 2012, even if it were for some reason to happen, and even if the core did start heating up, you wouldn't within 2 years have the surface of the Earth completely messed up, as happens in that movie. It takes a long time for the Earth's interior to interact with the Earth's surface. So I'm not going to, one path I could have gone is to debunk 2012, but once you've seen the movie, that's uninteresting. So, and also it's kind of like shooting fish in a barrel. So instead, what I thought I would do is, and it was an entertaining movie. It far exceeded my expectations. I really enjoyed it. Instead, what I thought I would do is walk through a couple of ideas, expose you to a couple of ideas, one of which you're probably aware of, one of which you may never have heard of, that are sort of scientific end-of-the-world scenarios. Okay, so before we proceed, we might want to ask ourselves, well, what do we mean by the end of the Earth? Right? Let's define our terms for a second. So, literally, what you might mean is to take the Earth and literally completely destroy it somehow. Right? So let's imagine you took the Earth and somehow magically, instantaneously turned all the rock the Earth is made of into tiny dust particles and scattered them irreversibly out to space so that they're no longer gravitationally bound to each other. Right, so we can calculate how much energy that would take. It's actually not that complicated a calculation. It's called calculating the Earth's gravitational binding energy. So for those who are more scientifically savvy, we're ignoring the energy it takes to actually break chemical bonds. We're just saying we took the mass the Earth is made of and tried to disperse it against the gravitational pull that tries to put it all together. How much energy would that be? So that's not a hard calculation. And the number, it turns out, that to disassemble the Earth and disaggregate and disperse it is about 2 times 10 to the 32 joules of energy. Now, that's, even to me as a scientist, I don't really have perspective on 10 to the 32 joules of energy. So to try to put that into some kind of context, what was that like? Well, it's like 10 to the 18th Hiroshima bomb. 10 to the 18th, which is also still kind of a difficult number to deal with. I've tried to come up with all sorts of everyday ways of thinking about this, and it's almost impossible. One website that treats this topic points out, and that's about right, it's about 1 week of the sun's output. Take all the energy the sun puts out and capture that for a week. It's about that. But that's actually, since you don't really have a feel for how big the sun is and how much energy it puts out, and neither really do I in an intuitive way, that doesn't really help either, right? That actually makes it sound like it's not a lot of energy. But the sun puts out a fierce amount of energy every week. Another way to think about it is, on the dimensional right over here, I was thinking, okay, so all of human civilization generates about a terawatt